Hello, my name's Mark Saunders and this is a YouTube video presentation on data types for statistical analysis. And by this I mean the different ways we can measure things numerically and then use these numerical measurements for statistical analysis. In this presentation we're going to follow the flowchart, which is figure 12.1 in my 2023 book Research Methods for Business Students, and we're going to follow this flowchart to understand the different types of data. But before we do this, we're going to look at why understanding data types is crucial for us when we're doing research. Once we've done that, we're going to move into different types of data, working our way through the flowchart. So we're going to look at categorical data, and in particular we're going to ask various questions about that so we can define nominal data, and within this dichotomous data, and also ordinal data. We're then going to look at numerical data, and within this we're going to ask two different questions which allow us to define numerical data either as continuous and discrete, or alternatively as interval and ratio. Once we've defined data, we're obviously with examples and the different types of these examples, we're going to move on to data measurement and precision, and how we can move from more precise data to less precise data, and then we're going to finish up with selected reading. Let's start by considering why our understanding of different data types is so crucial to quantitative analysis. The data we use in quantitative analysis can be classified into types according to the precision of the measurement made. The precision of the measurement dictates which statistics we can use in our analysis, and also which graphs and charts we can use, whether we use them for exploration, presenting the data, describing the data, or looking for explanations. But as you can see from the picture, there's a warning. Beware. It's very easy nowadays with statistical software to generate statistics that are inappropriate for the data type, and consequently these have little value and are meaningless. The next thing to be aware of is the more precise our measurement, the greater statistics that are available to us to analyse our data, and this is because more precise data can be made less precise, so we can go through an exact number of employees in an organisation, for example, to saying the organisation has between 5 and 49 employees, so we've moved from precise to less precise. However, less precise data cannot be made more precise. We're going to start on our decision diagram by looking at whether data are categorical or numerical. We're going to start by answering the question, can the data be measured numerically as quantities? And this question can be answered either yes or no. If we answer it yes, we get categorical data. Categorical data are data whose values cannot be measured numerically, but can either be classified into sets according to characteristics. So in other words, here we have data such as organisation, work group or department, or alternatively they can be placed in rank order, perhaps preference relatively of different sites for a new manufacturing plant. If we answer the question yes, we come to numerical data. Numerical data are data whose values are measured or counted as quantities, and these can be assigned a position on a numerical scale. So numerical data might be the number of sales an organisation has made in the last month, or the number of people they employ. We're now going to delve into more depth about categorical data. If we have categorical data, we need to ask ourselves two questions. The first of these questions is, can the data be classified into more than two sets, with answers of yes and no? The second of these questions is, can these sets be placed in rank order? And again, the answers are no or yes. Let's assume we've asked the first question and our answer is yes, and then we ask the second question and our answer is no. This gives us nominal data, data whose values cannot be measured numerically but can be grouped into categories. So something like sales regions of an organisation, or the different manufacturing plants. However, if we have answered the first question no, we don't even get to the second question. In this case, we have dichotomous data. Dichotomous data is, like nominal data, descriptive, except in this case that their data are grouped into two categories. For example, something you have or don't have, perhaps owning a car or not owning a car. If, however, we answer the first question yes, can the data be classified into more than two sets, and the second question also yes, can these sets be placed in rank order, we have what is known as ordinal or ranked data. Ordinal data are data whose values cannot be measured numerically, but they can be ordered or ranked. So ordinal data might be after we've interviewed people for a job, we rank them in order of suitability. Alternatively, it might be the rank order of preferred sites for a new location for a hotel. We're now going to look at numerical data, and once again we're going to look at the questions that are asked. However, this time we're going to look at the questions separately because there are two distinct ways of actually looking at numerical data. We're now going to look at the first way of classifying numerical data. This is by responding to the question, can the data theoretically take any value, often within a given range? If the answer to this is yes, we have continuous data. Continuous data are data whose values can theoretically take any value. It's sometimes within a restricted range, provided we measure them with sufficient accuracy. So, for example, if we were measuring a person's height, we could measure it to the nearest centimetre, or we could measure it to the nearest millimetre, or if our measure was extremely accurate, we could go more and more detailed. So it's dependent upon the accuracy with which we measure it. Examples of continuous data in business management might be things like share prices of an organisation and how these alter over time, or perhaps interest rates. In contrast, if we answer the question, can the data theoretically take any value? No, we have discrete data. Discrete data are data whose values are measured in discrete units, and therefore they can only take one of a finite number of values. So it might be the number of departments within an organisation, or the number of sites that a manufacturing organisation has. However, this is not quite as simple as it first seems. Where we have very large numbers of discrete data, perhaps the number of employees worldwide for an organisation, we tend to treat these data as continuous, even though they are discrete. This is because the numbers are so large, and it makes more sense to see it this way when we're undertaking statistics. We're now going to look at the alternative way of classifying numerical data, and this is an alternative rather than part of the same way of classifying. The other way of classifying numerical data is to classify it into interval or ratio data based on the answer to the question, can the relative difference between two data values be calculated? If the answer to this is no, we have interval data, and this is where we have data for the interval between any two values, and we can state this, but we can't state the relative difference. So let's say we've got a production process involving heat treatment, and the heat treatment involves heating the materials up to 500 degrees centigrade from room temperature. Room temperature is at 15 degrees centigrade, so that means we've got to heat them up by an interval of 485 degrees. However, that does not mean we're 48.5 times warmer. What it means is that we just have to heat it up by that amount. We can't state the relative difference on temperature because a value of 0 does not actually represent naught. It just represents the time and the place where water freezes. If we can answer the question, can the relative difference between data values be calculated with a yes, we have ratio data. Ratio data are data for which the interval between any two values and the relative difference can both be stated. So let's say we have an organisation and we're looking at the sales of this organisation. 3 months ago sales were at 2 million and now sales are up to 3 million. So we can say the interval between the two sales is 1 million increase. We can also say that sales have gone up by 50% from 2 million to 3 million. So we can talk about the relative difference and the interval. So let's pull this together and look at the two alternative categorisations we have for data when we're going to analyse it quantitatively. The first categorisation we have is where we can split data into categorical or numerical, and within this we can have nominal, ordinal, interval and ratio data. And this is often remembered by the mnemonic noir, black in French. Our alternative, again using categorical and numerical data, is to talk about descriptive and ranked. Obviously these are quite similar to nominal and ordinal, but then very differently continuous and discrete data. And with both of these, as we move down the page, we're looking at increasing precision, and this is important because it enables us to have a greater variety of statistics we can use to analyse our data. Let's look at the idea of the precision of data measurement in a bit more detail, remembering of course that more precise data can be recoded to make it less precise. So let's start off with some precise data. We've got share prices, perhaps in dollars at $43.2. This obviously is measured on a continuous scale, and so it is continuous numerical data. Then we have the number of full-time equivalent employees, or number of FTEs, 27.5. Again, we would treat these data as continuous. And finally we have the monthly sales of motorcycles, in this case 1,896 motorcycles. Whilst this is actually a discrete number, we would again probably treat this as continuous. Let's now look at less precise measurements of the same data, and in effect what we're doing is we're turning numerical data into categorical data. In this case we're turning everything into ordinal data. So share prices could be grouped as less than $50, between $50 and less than $100, and $100 and over. The number of employees, full-time equivalent, could be turned into groups such as 0 to less than 10, 10 to less than 50, 50 to less than 250, and 250 plus employees. Similarly, the monthly sales could be up to 9,999, 10,000 to 49,999, and 50,000 plus. So in each case we've made these data less precise. However, if we were to collect the data as on the right hand side of the screen, we would not be able to turn it into more precise data. So this only works one way. I'd like to now look at some selected reading. A book I wrote a few years ago with a good colleague, Reva Berman-Brown, Dealing with Statistics, What You Need to Know, is a very, very basic statistics book, but this describes different types of data and data measurement in Chapter 2. Andy Field, in his book Discovering Statistics Using SPSS, looks at data measurement and types of data in Chapter 1, and in my book with Phil and Adrian, we look at data measurement and defining the data type in Chapter 12. I trust you found this video useful. Please do look at the other ones on my YouTube channel, Mark Saunders on Research Methods, and please do subscribe. Thank you.